All right. Hello, everyone. Welcome to my stream today. Sorry, I'm running a little late. I'm not used to streaming so early. I had to actually rush to get everything done in time before I started. But come say hi in the chat if you're here. All right. Yeah. Hey, how's it going? Yeah, no. Hi in the chat if you're here. Yeah, okay. Clever. Yeah. Today, we're going to be looking at some like design level like topics. Some people commented they really like those deep dives I do later in the stream. To be fair, I know they're not as interesting for everyone. But I feel like sometimes this gives a little insight into what my work looks like. Which I don't know. It's helpful for me, just to kind of like work through these things and kind of explain reasoning. And it's different content, like some people come on stream and they'll be like live coding some kind of project that they've been working on for months, and they do that. I don't really live code that much unless I'm like doing a very specific demo that I'm trying to show off, or I'm like trying to teach something. So like for me, most of my time is spent actually working through the design aspects of problems, right? Which is a funny thing because it means that it's funny, I have This Week in JavaScript where, I talk about what's been going on and all that. And I find myself farther and farther away from it, especially as the conversation has been gearing towards stuff like AI, because like, like it's really funny watching all these like vibe or seeing all these like vibe coding, comments and people talking about all this perspective. And I mentioned this a couple of weeks ago. Just like what I do is the opposite of vibe coding. If I get to the code, hopefully I've already figured everything out. Um, so it's very different kind of zone. As I said, I find I've been finding the last while, especially being very disconnected from like, this week for most things, because the topics of interest right now are just so far from anything that I find interesting or important. Dan Aber, Dan Abramoff posted another post today. Yeah. I might have tracked that down. He's been posting weekly now for like the last month, which is interesting. I have to admit, I think I know what he's doing, right? What Dan's doing is he's trying to find the right framing that resonates, and I think he's realized that not everyone, a single framing for RFCs work for everyone. So he's like, what if I approach RFCs as HTML or as functional programming or as two servers? He's trying to come up with like different ways to like say the same thing. Of course, for me reading these posts, um, especially after the really long one, the first one I did, I've just like it's just been like it's like reading the same article 4 times in a row. I think different people get different things from them though, because I think this is like certain gap. He's gonna write 10 versions of YRC post works until it works. Is good until it works. Yeah, something like that. I mean, sometimes that's what it takes, right? You write the same thing enough, you come at it a slightly different angle, and suddenly it like clicks for people. Um, we'll talk about RCs maybe a bit later. That's at least a topic I can talk about. I have some thoughts and notes because I actually got in first time in a long time of a little bit of, it wasn't a discussion, didn't really respond to me, but some comments in RFCs with Dan on Blue Sky for the first time in like almost over a year. So can kind of talk about where, perspective where RFCs sit now and stuff. Yeah, no, I mean, freaking hell. I mean, if you really want to talk about like, yeah, I mean, this is always the problem with this stuff, right? Like, there's the actual, like, there's like the truth of the matter from like how things should be, and then there's like the reality of the matter. And I mean, if you want to talk about like just like not caring at all, I mean that's a perfect back and forth thread, and it blew up. I guess we get Uncle Bob's. What is he wearing? Like a one of those like towel bathrobe things. I don't know. Just when that's the interesting point of discussion and not the things that we can be creating. It feels very distractionary, very almost like 1984. I mean, but content creation needs to come from somewhere, right? So, I mean, I was thinking about this. I mean, sorry, this has nothing to do with like the general like topic stuff today, but like obviously most content creation is reactionary, right? And it's because a lot of the value people find in content is that like there's a lot of information sources out there, too many for people to actually discern themselves. So we get to this like point where we are depending on others to kind of filter down that information for us. And the power of good content creators is that they can like you know make the takes that are either interesting or best represent like what your take should be. They can make the critical decisions for you essentially, and then you can just like repeat it, and this helps you not have to discern the wide amount of information out there. I don't know if that's a pessimistic view of things, but like it has value. um but like at a certain point it's the same echo chamber regurgitated conversations over and over and over and over and over again, and you just keep on going like, why can't people be excited about you know something new or something different? And I mean, you can kind of get why though if you think about it from that perspective. It's like if people are generally looking for how to like discern all the information to a single opinion, then um why would they want different like information out? Like they're trying to get rid of the information overload. Why would they want more information? So it's like, I don't know, that and AI together, just they're a wonderful pair of like mediocrity. I don't know else how to say it. Yeah, this is a green screen. Green screen in my own office. Just like I can't sit this angle, otherwise I'd be facing the door. Yeah. Sequel is bad. Gets into a bathrobe. Yeah, I mean, whatever keeps everyone entertained, right? Um, Prime reacts to Theo reacts to Rich Harris. I wish it was reacts to Rich Harris. At least, uh, if this was real, I might even watch this. Right? The problem is it's not even. I don't. It's not even Rich Harris at the end of the line. I mean, he might be hidden like 4 more layers down. I don't know. It's interesting. Is it just a lack of new content? I watched a video the other day from Theo. And he was reviewing. He's now reviewing like like original um React talks from like 2013, which are great talks. To be fair, I would review those on my channel. I think I might have actually reviewed one of Pete Hunt's talks a while ago. It was really interesting. He spoke for a bunch of students at college. I can't remember if I did that on screen. And my favorite, the thing I want to point out is how secular, whatever, cyclic, whatever these patterns are, because he goes on a big thing about why like what he called KBO, or like basically data binding and like smart data flows are bad. Like he's very functional programming oriented. Pete Hunt was. And immediate programming, like why in game engines, like you could tell he has a graphics. He probably has some kind of graphics background too, not just functional. Like you could tell that like basically things where the data is special was not where React wanted to be from design, and why it was so elegant. Yet when you take his talk and you think of React in a post hooks world, it's like every single criticism he had of the other solutions that weren't React, you could now point directly at React. So like there's a reason why these elements exist, right? The reason React went to hooks in the first place was because of certain compositional aspects, because you know they needed rules around execution and lifecycle and data. You couldn't just naively re-render everything, because if you naively re-render everything, it's really inefficient. It's the same reason why under the hood in some, the new stuff with graphics like Vulkan and stuff, there is some retained mode stuff going on here. If you just immediate mode, you can't, like, immediate mode or like re-render everything will always be less efficient, right? So like the actual battle isn't whether like these like at a purity sense these things are actually better, like, because they need aspects of the other. Like, it is true that when you keep state around, it gets complicated and it gets messy, but it's also true that when you blow everything away, that it's not efficient. So like it's a question of whether you can provide the developer a certain mental model that lets them think one way and have it like be optimal where it needs to be. And that's been the whole debate, versus being like, you get it, what you see is what you get. So I don't know. This is, I'm just kind of rambling right now while waiting for people to join up on the stream, but it is kind of a interesting to kind of see how much like 10 years puts on certain perspectives, and how nothing is as pure as we'd like to think in our ivory towers of design. But it's something we have to consider from a design perspective. And that's really what I'm aiming at when I'm looking at here today. Like, I want to look at design issues, because that's what I do in my work. I don't vibe code. I look at what other people do, but I don't often react, like, or react to the react. Like, we're in a zone here where we want to hopefully create new novel approaches to problems, so that we can further or better what we're capable of, not just there's important parts of the cycle. Sometimes the goal is to make something easier that's been done before, but at a certain point you have to also do what's not done before. So that's why I'm here. That's why we're doing the stream. That's why I like looking at these problems and kind of thinking about it. Why I have incredible respect for the other people working in this realm of trying to think out new problems. That's what and solutions in these spaces. Everyone from Rich Harrison's latest async proposal, we might take a look at that, to a lot of the work that the React core team has been doing. Right, it's easy to get caught up on like in this space, like how to get caught up on like how things could work in this like perfect world, but there's a certain rubber meets the street thing going on, and that reality has to always be part of our consideration when working in design. All right. Okay. Yeah, no, I'm streaming early today. The reason that I'm streaming early today, and it's going to be probably this way moving forward, is that recently, I think I mentioned, had a baby, and I'm actually doing school drop off and school pickup. So I actually have to sandwich my streams in between that now, instead of being able to just take the whole afternoon. So we're moving earlier, and maybe even a tiny bit shorter, but that will not get in the way of us being able to cover some incredible content. And as I said, very excited to have you all here in the chat. We can talk about these topics and kind of look at what goes into these designs, and even provide some feedback. Let me see here. I'm actually opening up Twitch now, because I haven't got that up yet. Yeah, we got some people in there. There we go. All right, there we go. Thank you. All right. Yeah, I mean, it's awesome. Sometimes a bit tiring, but definitely awesome. Okay, so we should probably get started with some actual topic for today, because I'm have notes to work with because I had that I took that time off. Um, so I have to actually sign into HackMD. It's been so long. Um, I actually what was I going to say? I actually had a bunch of notes sitting on reserve. I didn't even. I looked at them last week while we were going, or 2 weeks ago when we were doing the stream, and I actually was like, nope, don't have time for this. But I actually have like several of my written notes on the topic today. And the topic today I'm looking at is SSR, primarily looking at reactivity and async in SSR. Um, and I think a bit of this might help to start with understanding how SSR works in most solutions. Um, I know we've covered this in the past, but I mean, let's get into the fundamentals. People can ask questions, and then we can kind of go from there, right? Let's see here. Share my screen. Oh, and this is one of those things that I don't think people realize about some of the solutions, like because you can get really far without certain niceties or tools. At one point in that post, Rich actually lists off a whole bunch of features that he's very excited this unlocks. I'm like, crap, Solid's had all of those features for 6 or 7 years now. Like, oh, not from what like right after 1.0, but actually before 1.0. Actually, there were things that I wanted to get in for 1.0, and I started remember thinking like Solid was surprisingly full featured. People can talk about the ecosystem and people can talk about like, oh, there's not enough libraries and support and all this stuff. But it's like, what can you do as a developer? Like all I could do was basically give people every capability that they could want, and hope that they build with it, right? I can't build 5 different ShadCN component libraries, but what I can do is give you streaming, async SSR, automatic serialization, you know, like transitions, you know, like so like I don't know. It's interesting when I mean I don't. Sometimes the argument could be like maybe you don't need all these things and they're just kind of nice on and like there's other things that should get priority, right? But it's like it's a tricky kind of balance, right? Because it's like you build the thing, you hope that people, like yourself, generally, it's always a little self reflection, will like, because you kind of imbue your own personal perspective on, how to solve the problem when you build a framework or tool like that. And it's like, it's, it's interesting when you basically build all this stuff and then like people are like, oh, it's not necessary, or we don't need this, and then like 5, 6, 7 years later they're like, yeah, this was always the way to do it, and you're like, okay. you know I think I have a Dan Abramoff post about that in concurrency, and I released an article this week actually about how I've been working on Solid for almost 10 years. In a few months it will be, but this will be my 10th year of working on Solid JS. But the truth of the matter is your average end consuming developer is not going to notice this stuff. So like, it's not a bad bet to not build out some of the features and stuff. Like, I mean, I think I might have said this before, like from that kind of depth of perspective, like I think things like Quick are incredibly ahead of their time, in terms of capability, things like the resumability. I think these are topics that people will in, 5 years ish, 5, 6 years will be like, oh yeah, this is something that's important. But right now everyone's like, yeah, what's that crazy quick thing in the dollar sense? Like, they find reasons to pick at it based on stuff, and part of it is legit. Ergonomics are fashion, right? Like you there's things that are deemed acceptable that weren't acceptable before. So like signals are a perfect example. In early 2010s, a lot of people didn't think something like signals were acceptable. They were too magical. People weren't used to paradigms like this. It was too big of a shift from where they're going. But after 10 years of React, it's like, thank God there's a different option, right? But it did take those 10 years. So there is that aspect of it. But on the other hand, I mean, maybe we shouldn't be so focused on fashion. Like maybe we should look at the capabilities. These are interesting things. Like don't get me wrong, from a design perspective, when you're building a tool, it's always a marriage of both aspects. You need to be aware of what's usable, understandable, accessible to your end user, and versus like the raw capabilities. Otherwise, like vanilla JS is the fastest or the best or the most efficient or whatever. Like it always is. But um, it's unwieldy to build certain things just purely that way. You build abstractions. You do this. So like you have to understand that like the job is, in a sense, finding good developer experience for solving hard problems, right? Your goal is to let people get to a place where they can do something that seems relatively simple for them, and then get results for something that is, much trickier to accomplish. So one, it's like two sides of the same coin. One can't be approached without the other. So it's not like these live in space. So, when things are ahead of their time, they are legitimately ahead of their time. But I think they should still get our respect and understanding. Um, as I said, I think Quick, for example, and its resumability is one of the least respected future technologies that's incredibly relevant, right? In a sense, like when I look at the scheme of things, React server components are just a reimagining of what Marco did, 10 years ago, right? They're a better version, right? Marco didn't get everything right, but that's like the push on that. When I think of what Quick's doing, it's probably going to be a worse version of what we're doing in 5 years. But I think it is something that you know people should like at least understand that this is a thing. It's not just like, oh, you're not going to need it. Go find, what was it, Michael Jackson or Ryan Florence? They had a Twitter post in 2016 being like, oh, no, it wasn't Ryan Florence. Ryan Florence was always in, but Michael Jackson is like, oh, server side rendering, not going to need it. And it's like, technically, yes, but like 4 years later, you're building a server rendering framework, right? Like, we have to be careful with absolutes, especially when it comes to the advancing of technology and fashion. So, like, web components are ahead of their time. Yeah, that's an interesting one, right? For me, I feel like web components were behind their time. Like it's the other thing. I think web components are exactly what I would have wanted back in 1997, or maybe by 2000, no, 2003, 2004. That's when I would say that I realized. And then it took 6 or 7 years for them to kind of get there. And then and people are like, okay, we should make a proposal for this, and then they finally do it. And then like 20 years later, you're ending up with like, it's like when you end up with how I said that like RSCs are maybe a slightly better reimagining what like Marco did 10 years ago. Web components are like, what if you just got what Marco did 10 years later, you know, and actually maybe a little bit more compromised because you had the appeal to like the lowest common denominator. Yeah, I think that's how I'd take it. Um, but that being said, technology that's like old comes back again, because like usually when we cycle along these things, it's not just because like we do the spiral staircase up. It's because like if you go really far one direction, you start realizing that you lack something else, which causes you to swing back the other way, maybe too far. And like a perfect example, as I said, is Remix has got that feel for me, right? You kind of get back to that like PHP days of things, right? When I think the real answer is slightly more granular, kind of like TanStack, but sometimes it takes swinging past the mark to get to where you need to go, right? And in a sense, I think this is like web components can give us that sort of like where to swing back to when we're like, look, stuff is too complicated. There's too much going on here. We need to somehow figure out how to make this base level. As I said, the only problem with web components isn't what they in a lot of ways what they accomplish to do. It's the fact that they're too ambitious, like, and then they encompass too many things. If you kept the pieces small enough and fundamental enough to serve as building blocks, and then the parts that didn't fit could always be not used or swapped out as needed. The problem is because it's too all encompassing that it's web components. I know it's 4 different specs or whatever, but because it's web components, that's the problem. If you're like, okay, I like custom elements, but the shadow DOM's no good. But even the shadow DOM's too big. Basically, like the problem there is like you built a framework for the platform, and then there's 14 other, the KCD people who think they have a better version of building a framework that doesn't work that way. And the thing is, they're not wrong. So it's like, fight. Like there isn't much option there. Instead of coming up with something that was actually fundamental that everyone could actually leverage, we now have just another standard in the standards pile. So it's like, yeah. Anyways, we don't need to talk about web components much more. They're not really worth our time. Okay, let's continue on, because I've already been going for 30 minutes and we haven't really even touched into the topics today. So yeah, should we just jump right into, let's see, I've got my scale draw here and I'm zoomed way the hell out. Right. Yeah. See if we can find some space on this chart somewhere to kind of do. I haven't actually decided what I want to draw yet, to be fair. I'm just trying to think of, like, generally, what do you all know about SSR? SSR is actually very, very simple process, and it's important. We could differentiate it from like traditional server rendering, but there's too many similarities at the beginning standpoint that you're not even going to really make that much of a difference. The biggest difference between SSR and other server rendering stuff is the templates generally aren't designed to only work on the server. That's generally how you can differentiate it. When we say server-side rendering, we're like saying like we're taking something that maybe isn't primarily server-side and making it server-side rendering. That's why we're denoting it. Otherwise, you'd just be like, I'm just rendering some some HTML. Like, why is it server? So why is there that acronym? Draw a black background, draw a rabbit. No. I'm back to white backgrounds. Black was fine, but I'm back to white. Sorry guys, I know it's bright. Yeah, Elm did do that at one point, and I think for Elm's functional model, it's much purer. But Elm's also very academic in that sense. I think that, that's it. I think that this is one of the challenges about where the rubber meets the pavement, so to speak. So, okay. All SSR is, for definition of today, is we're going to take some kind of potentially client side templating, and we're going to render it as well on the server. That's the baseline of SSR, right? And by rendering it on the server, all I mean is generate strings. So you have something like JSX or Svelte template or whatever, and you're going to generate strings, right? CSR pre-render, sure, is the thing, right? Pre-render is always a funny term because you're like, do you mean at build time? Do you mean at runtime? See, it's not that big of a difference. But like generally you get strings, and I mean I can just let me grab a solid playground here for a moment, and I don't even know what this example is showing me, but if I look at the output here, see, this is the JSX output, but if I switch to server-side rendering output, and this one's too interactive. Let me do something that's simpler. What you're going to see is, yeah, it's not even the point. Solid's implementation, this is like almost like a tag template literal. It's literally taking an array of strings here for the button. So the button, this attribute, and the button, and then basically there's a hole here and there's a hole here, and then we fill that hole in this case with a hydration key, which we'll talk about later, and then the escape text of the child. So essentially what this function does is it does a little bit of processing, but for the most part it just adds strings together, right? And if you go to svelte.dev, hopefully they still have it up here. Where's the playground? What do they call it? What do they call their playground? The REPL? Is it still playground? Okay, they call it playground. Sweet. Hopefully we can see. I know they've updated theirs now to use like stack blitz, but if I go in here and I see again, client side, you have like some DOM manipulation. But if you go server, yeah, they're just adding, literally, you can see the adding here. They're like, here, add this string over. See, they can tell this is static. And in fact, Solid could tell that this is static as well. So I need something that can update. So let's say on click name plus equals exclamation mark. Okay, guess what? Now we're back to the example I was showing with Solid, where you have the string, and then you have the escape. See, told you there's always the escape, and then the string again. Again, we have an SSR function. The reason for that is to handle nested recursion. I'm not sure Svelte has to worry about nested recursion examples, but essentially it's the same idea. You're just jamming a string. If I go to Vue, you're going to see, I believe now, string as well. Classically, Vue was not like that though, and nor was React, nor is Preact, whatever. Because the way React works is that, see, things like Svelte and Solid, which use a compiler for their templating. To be fair, React uses a compiler too, but there's a difference when you have a compiler that has options like this, like, oh, we're doing client, we're doing server, and a framework where like they're like, we always generate basically the same JSX. And the React, has one JSX transform, and you just happen to run that JSX in different environments, which is kind of a cool thing, right? Because conceptually you're like, okay, like this part of the step isn't platform specific, right? Classically, because Svelte's compiler basically compiled in, and this is not true of Svelte 5, but if you look at older Svelte, like basically compiled in like the DOM operations like straight in as part of the compilation. It made it difficult for them to do like universal rendering, right? What they would do is Rich wrote a separate like Svelte GL thing, right? Where Solid used its reactivity system as kind of a replacement for the hierarchy of the virtual DOM. Like there is actually decoupling between the reactivity and the DOM specific operations. And Svelte 5 is like that as well. I remember someone coming in our chat working on the Svelte team was saying that I'm working on a universal renderer. It was very for Svelte 5 and is very inspired by the Solid one. But my point is, having some capability, like in the Solid playground here, we actually have this, you can say client side with hydration, you have slightly different compilation here again. It gives you this ability to kind of tailor for the environments a bit, right? And there's no DOM on the server. The reason the server has a separate compilation is because it's more optimal, right? The fact that there's no DOM on a server is actually, a pretty big deal. I mean, you could bring in the DOM, but that is kind of slow. Why do you need that representation? Even the React's virtual DOM approach is pretty slow because you actually have to build the virtual DOM and then go, okay, now that I've built this, run through this object and turn it into strings. It's much faster to basically just be like, I'm just going to append strings as I'm doing it, right? I'm just going to add these strings together. Let's see if, where was I? Output, server-side rendering, like, let's just smash these strings together. Button, hydration key, type button, escape, right? But this is a simplistic look at the systems, right? This text is too small in the Svelte playground. Yeah, it's because I don't hang out there as much, so I don't have it set up. Thank you. But yeah, I was just showing it's very much the same sort of approach. Yeah, exactly. And it's interesting. I'm sure Hono's server side rendering of JSX is similar. The funny thing is, this is a great way to approach it on the server. This is a terrible way to approach it on the client, which is why a lot of these solutions that are like built this way for server rendering JSX are actually kind of terrible for their client side implementation. Like when they're like isomorphic, like I don't know if anyone finished making Hano's JS framework benchmark, but it was definitely competing with like Blazor and Alpine. So okay, this is great. End of story, right? We're done. Um, well, there's this thing called async, which is kind of a pain. And the reason async is a pain is you can't just make everything a single string. Well, you can if you fetch everything ahead of time, right? See, React, even with its virtual DOM and everything, still had render to string, and we all have like server side rendering. We have this ability to say, give me the string synchronously. How do you solve the problem if you have something async? And for the longest time, the answer was prefetch. But I mean, that's tricky. What if you're fetching deep in the components? How do you know what to prefetch? Well, get server side props or whatever. Like you could make hooks in to a build system compiler and basically like hoist out um, the data fetching, and then it could know it, right? And then you can basically do that ahead of time. And same principle with Remix when it came out, because you have to remember Remix was created before React actually released Suspense in a like for data fetching. And that they actually Remix team actually ended up like creating their own mechanisms that are like Suspense. They created their own streaming mechanism. They basically had to do everything themselves because React wasn't ready with a solution at the time. But what I'm getting at is that's a solution. You can kind of pull all the data fetching ahead of time, and then kind of just render it. But that doesn't help with streaming. To be fair, that just means that's your classic SSR where you do all the data fetching and then you send everything when you're done. Which means that your request responds at the speed of your slowest data coming back. Which is why people used to say stuff like get server-side props is cursed or something, right? And a lot of Next.js apps actually ended up just doing fetching in the component anyways. So they were only like half leveraging server-side rendering because I mean they kind of understood that like if the page has to wait for your slowest data request to finish to show anything, it's kind of awkward. So a lot of them would like maybe like do some basic stuff and then basically fetch everything in the client. And that was actually kind of the state of SSR in 2018, 2019, which is kind of funny because I didn't think that I would have assumed most people were going to do like the data fetching using like server side props. But I think we'd already kind of done full circle because I was looking at all those demos, like real world app. You guys remember the real world demo? It was like a medium clone that you could do in every framework. This used to be like the demo to make, when people are like, I want to show that my new JavaScript framework, is capable. This used to be this was the demo because you could basically show that you could do auth, you could do data fetching, you could do rendering, pagination, basically every feature that you need in a framework, you could basically do through this demo. But it kind of fell off popularity. But when I first came into this, I was doing client side, and most people wanted to do like full stack. This is where you could show up your Sapper or your Nuxt or whatever. And I was destroying them on page load because they were all doing that wait for the string technique. And I think real world people realized, okay, yeah, I'm just going to fetch in my next components and not use get server side props. But which is so much so that when Remix came out with their loaders, people didn't instantly go, oh, this is the same thing. I mean, they should have, but they didn't. They're like, oh, this is novel, just because people had gone so far away from it in Next by the time that came out. Anyway, okay, so that kind of sucks. So let's talk a bit about how can we solve async so this isn't the case. And one of the ways is make async discoverable. And by that, I mean, like, as part of the rendering process, instead of saying like, let's do everything ahead, you can basically go like, as we're rendering, we're going to find what's async and then do something like a boundary of some type. Like this is the suspense boundary. Marco, again, what's it called? Async fragments. Just giving them a quick shout out. It's worth doing. But they described how they came up with a streaming solution, which is basically a discover as you render solution. This is like Suspense back in 2014. But if you look at this, they have this async fragment data provider. So it's not as nice as API, but essentially they broke their HTML into bound sections and said, look, as stuff finishes, you can send it to the client, and then we can just swap these in later. And I've done whole streams on streaming, but the gist of it is you can just keep on appending HTML to the end of the document, even after it's been closed. And HTML is just, it's very self-correcting. You can stream stuff even in order without closing the document, and the browser will somehow figure out how to render it to the best of its ability, because like closing tags are kind of optional, right? So like this is really the approach. I mean, another option is, I think Svelte had an await tag. Again, they didn't really do it the same way. But the idea with the await tag was you could like, because I think originally the await tag only actually properly worked in the client, even though you could see how it's a similar mechanism. The biggest difference between the await tag and Suspense is the await tag requires that you pass the async, like the promise, to the block. I'm trying to remember if Quick's approach is like this too. I think it might be. They have like a resource tag. But basically, you get to the block and you say, wait this block on this promise, right? And you can kind of see this like as a fairly decent approach to doing this, because you can just be like, okay, I can render part of my page, not wait on the slowest thing. And then when I hit a promise, block it out, right? Right? Web components spotted. Web component function, web component syntax, but not actual web codes. Marco uses tags as their code. So this so what Marco tends to do is actually, and actually, to be fair, this is the output. You don't actually write a async fragment. Marco could kind of do this automatically later on. Anyway, but yes, because it uses tags, it's not actual custom elements, but it uses the syntax, because you can, I don't know, a lot of people know this. The biggest thing custom elements add is lifecycle to tags, but you can always just like make your own tag up. A lot of times we use dashes for the same reason custom elements uses dashes, for the reason of not conflicting with the existing thing. Like if you have a dash in your name, you know that you won't ever have a like namespace conflict with native elements, because native elements cannot have a dash in it. Anyway, what React ended up doing with Suspense, which was interesting, was instead of just putting the promise at the boundary, because the challenge with putting the promise and the await tag is that if requirements change down here, you have to go and start adding things to this async, or add your own, maybe you should add your own nested async fragment, but everything has to be kind of hoisted up to where that fragment is. And what Suspense is, for example, is an inversion of control. It's like saying like, hey, child, try to render, and whatever you can do, it's fine. But if you can't finish, I got you, right? It catches any of this stuff that can't be rendered and says, I'm going to show a fallback instead, and you take as much time as you need, right? And what this does is this inversion of control meant that you don't have to know it above. You could localize kind of data fetching, or not data fetching, but async requirements. There's a difference between data fetching and async requirements. You can imagine there's still benefits to fetching earlier, i.e. higher up, because if you nest things inside, you could picture that, like if something blocks something that blocks something, you get waterfalls, right? So there's a difference between the question of like, can I render this currently, and fetching down there. But what I'm getting at is, this is the kind of approach we took to SSR. Generally speaking, we recognize that there's bounds inside parts of the HTML requirements. So, but What do you do within those bounds, right? Because the tricky part is when the await's on the outside, when it's like literally like the await tag, then you can just get there and go stop, you know, and then you go continue. But when it's discoverable inside and you have to bail out, then you end up in this kind of interesting zone where um, you more or less maybe have to re-render stuff. In the case of React, it tries to render, and then when it fails up to the boundary. It's like an error boundary. Suspense is very similar to an error boundary. And then when it finishes, it tries to re-render it again, right? That was the classic model for how React handles the server, which can be kind of inefficient. To be fair, and the reason I'm bringing this up is that's how Solid works today as well. Solid has this like crazy, beautiful run once, retained mode, ultra performant approach in the client. But then when it hits a suspense boundary on the client on the server, it's just like, oh well, let's try again, because it was simple. When I was benchmarking Solid's SSR rendering, it was like several times faster than most other solutions. So I was like, oh, what's the cost of just doing the server rendering again for these fragments or suspense boundaries? Because if you're already like, you could do it 3-4 more times, whatever. If you're already 10 times faster, like, who cares, right? But maybe that's an unfortunate side effect of this whole thing. But it's the key part is once you go down this road, smash to string doesn't it becomes tricky, because you either, as I said, if you smash the string like this, you have to re-render it again, because you can't go, oh, this name is async, continue where you left off. You're just like, okay, go to the boundary and smash to string again. That is kind of the problem, and that's exactly, as I said, what Solid does, right? We keep while we're server rendering. Well, actually, yeah. Now I'm getting to the heart of the matter. If you fetch below a suspense boundary or below like an async fragment here, and people are familiar with this with client-side React as well. If you're fetching below and it's re-rendering it, it's gonna, the most naive thing it's gonna do is fetch again every time you hit the component again. First time, from its perspective, this wasn't here before, it failed, it errored, it doesn't know the state inside this boundary, it's garbage. So it goes, runs, fetches, renders some stuff, sees that it's not ready, bails out, collects the promise, finishes, runs again, hits the fetch again, and then fetches again, fails. How does the old promise from the last run get into the new promise in the new run if you're just re-rendering it again, right? And the truth of the matter is, stuff like use memo and React, like hooks, don't actually protect you in this case. This is why people have had such a hard time implementing suspense, and there's that whole fetch up, hoist up your fetching thing. How do you establish that these are the same thing? And there are solutions. The reason that memos don't work in React that way is actually a slightly different thing. You could pretend or conceptualize that they could work in React, that you could keep the reference. But in a system like Solid, which doesn't have that kind of reference stuff, how did I solve this? Well, hierarchical IDs, right? And the funny thing is, I found out React does something similar themselves. If you actually, how does use ID work? I Googled this a while ago, and I came across, what is this? How does use ID work internally in React? Right? You have to remember, use ID or create unique ID in Solid gives you an ID that's the same on clients and server rendering. Right? And they go into this, but they talk about the fact that they use the fibers inside. They're actually looking at the VDOM tree, and they're like, get tree ID identifier prefix, blah blah blah. They're building up basically this code based on its parent, because if you have a tree of structures and the tree can change shape or things can be added and removed, it's possible that things get created in different order, especially with async. It's possible that like one thing resolves first this time, if something else resolves first another time. But as long as the decision of whether to show it is above that resolution point, then that's fixed. So essentially, you can use the hierarchy of the virtual DOM, for example, to be able to come up with stable IDs. And this goes through this whole thing explaining how um, like the fibers basically end up being able to generate this hierarchical ID. And to be fair, I wasn't aware of this. Honestly, this hadn't come out like as a public API at the time I was working on Solid Solution, but Solid's hydration key is almost identical to this because the idea is, look, if you have data fetching, you could set a key yourself, but if you want the system to, like, if you just go, hey, I want to fetch this data, like in a component below some suspense, and you want it to just work, and it's doing a rerun model, well, you need to be able to find it again when it runs again. And so I basically came up with an ID scheme like this, which essentially would match up. So when it reran the tree, it would be able to find the resource again and go, okay, I've got the promise, I can continue. Right. As I said, it's funny. I released the solid version before React released this, but if you go back to earlier versions of React, internally, React had hydration IDs on their DOM nodes for SSR back in like the 0.14 days or whatever, like way back in the day. They changed their hydration approach to be better around React 15, I think. But they've always had this ID system on virtual nodes. They just didn't expose it to you until after. Like, see, look at this. You can see it here. Z0, 1, 0, 1, 1, 1. Anyone who used Solid should know, like, this looks very, very similar to our hydration keys, because you essentially have to mirror the tree. In their case, it's the VDOM node tree. In Solid's case, I used components because I didn't really care about this individual elements. I need it for context. So essentially I used components. But there's other, like, you're dealing with a hierarchical graph. So it's just something to consider. So this is my kind of preamble. So you start understanding the problem space when you're doing re-rendering, when you're doing async operations. It's not enough, and this is why it's taken a long time, and why you need these foundations for this stuff. This is why Svelte hasn't done this in the past 6 or 7 years, or I guess Svelte's turning 9 pretty soon here. I mean, it's possible because I mean, okay, old React they create their elements one at a time, and because it's JSX, they could be created in any order anyway. So like Solid clones templates, so we actually only need we actually generate IDs per block of code, where React creates their elements one at a time. So I feel like this is like a historical thing in terms of like they basically, every element could be matched up one for one. Right. They don't need to output this anymore because when you have hierarchical IDs, I think they realized at a certain point that if they changed their state management of it or did a few things, it's basically predictably consistent. So like it will render the same on the client on the server, which means without rendering the IDs into the page, you should get the same output on both environments, which means they should just match. I mean, this is the source hydration mismatch, right? But conceptually, if if you basically have the right kind of state mechanism and you have this hierarchical system that keeps uniqueness this way, you should be able to match as long as things render the same way on both sides. Couldn't a lot of these components be avoided if creating things weren't primitives but components? Well, it depends. If you want to say it is the suspense boundary, then you don't need it, but then you don't have inversion of control, which doesn't scale, right? Like if you want to say it's an await component, for sure. Otherwise, the fact that it's a component or not, like whether I'm making the ID because it's a primitive or it's a component. As I mentioned, with Solid, we use components for doing this. Doesn't matter. I still need this hierarchical ID system that, in theory, I wouldn't need otherwise. With Svelte 5, we gracefully support mismatches in SSR and client as a feature, so we wouldn't use the tree. Okay. And by gracefully support, I imagine like client heal. This is one of the places where I've been like trying to figure out where I want to take a position on it. Because again, this is like I've been nerd sniped by Quick, and like part of me starts getting to this zone where I'm like, should the client be able to heal? Because that would presume that certain code would have to get to the client eventually. So I mean, I started this progress in 1.8, and again, I don't know if it's completely right, where I started being less forgivable for hydration mismatches because I think ultimately like it gets us to a place where like we shouldn't have the expectation that all the code will make it to the client. I know this is like thinking like really far out, but and it's less happy place, but I mean it's kind of like one of those like stick your foot forward and this like hope it can keep on walking. I guess we'll see. I think people should like the stream. Yeah, I agree. Like, subscribe, follow, comment. I don't know. Very much appreciated. So yeah, this is an interesting thing. Like there's a couple aspects of the solutions that lead to this, but I wanted to point out that it's compounded to have different content for the server than the client for better UX in the case of progressing, which is the line to the future solve. Okay. Yeah. Yeah. I guess it's a question of whether those kind of situations should be special cased as to guard future features for cases where they should be the same, which is, I think, the majority case. Yeah. But yeah, progressive enhancement's an interesting one. Or what I like calling it, graceful degradation is like what my favorite term for progressive enhancement. Anyway, what I'm pointing out that the ID here is actually mostly for less like I know we're looking at DOM elements here, but mostly for linking up resources in this case, right? Linking up async fetching. So you like when you do the re-render, you're like, it's the same one, right? We don't need to necessarily render this into the HTML, but the fact that like when you make the structure again and you can find the async thing, you can match it up automatically. Otherwise, like you could also say, user, provide me a unique key. You could be like, what is this query called? Then you could match it up too. But this was like, if you want, this is one way of coming up with a unique key in a tree. Okay, so I think this is probably enough preamble to kind of get like where I'm coming into these problems, because I started a while ago kind of coming up with like different approaches here, and I wrote a bunch of hackmds, and I want to talk about a few of them today. One of them was my 2.0 SSR plan, but before that, let's talk about I like spitballing out, and I'll share this in the chat, ideas like sometimes I think it's an important exercise where you go, can we do something just without it? Like get rid of it. Like as you guys know, when I was working on async, I wrote a whole bunch of stuff. It's like, screw transitions. I don't like transitions. Let's not do transitions. What would the model look like? So sometimes it's useful to kind of go through the mental exercise. If you take something you assume that you need and you just get rid of it. And that is kind of where you have to start here, because I just went through a whole tangent about suspense or boundaries of some sort being the governor of how we do streaming and doing async and SSR. So the first question is, can we get rid of them? Can we just do SSR without async, without boundaries? And let's talk through that a bit, right? So yes, the short answer is yes, but I want to dig a bit more into what makes sense or not, and consequences of different ways this can be handled. which brings us to our first question. Should we wait for async when we encounter it outside of suspense? Yeah. So what I mean is if you just have, yep, an early stream, yeah. This might be my new time because of school pickup and drop off. So and actually on Twitch, am I streaming the right category? No. Every time StreamYard switches me back to um, talk shows and podcasts. Really annoying. Sorry, just a second. Let me update that. I want it to, what am I? Game development, software and game development. There we go. Finally. Okay. Okay, let's so I always forget to do this. Anyways, let's continue on. Where were we? So this is like we were looking at our async example, when I was talking about this async fragment and I was talking about like, doing data fetching or doing stuff, you know, is it possible for us to just like forget about the boundaries and just how could that work? Because in a sense, one way of knowing we're done is by putting a boundary around it. Another way is collecting all those promises that are in the UI and deciding when we're done. So basically, if I go here, I go, which first should wait or not to wait. Solid and RCs have taken the opposite approach here, but Solid 1.0's approach didn't wait and didn't really work in a lot of cases. Basically, we only lazy consistently worked. So async SSR without suspense was basically no go. In Solid today, if you try and do async without suspense, it doesn't work. If you've seen in RCs, what they do is they actually almost have like an imaginary suspense boundary around the whole page. So it actually holds, like the old async hold. Like if you don't do anything, you just put async on your page with RCs, like make async component. It will do that behavior that nobody likes, where it waits till everything is rendered and then sends it back, which seems like a reasonable default. Although client side, that doesn't work, right? Yeah, so what is it? This is pretty convenient, is it lets opting in to be more gradual, and Next has used this to do things like PPR, right? Because they basically assume like if it's above the suspense boundary, it's like static. That's essentially the gist of PPR. But RCs are not isomorphic. They only run on the server, so there's no consequence of them behaving this way. They can't update in the client. If a client component under them were to throw a promise and no suspense above it, things would not go so well. Because as you know, in React, if there's no suspense boundary to catch it, it crashes, right? In Solid, our async model doesn't require suspense boundaries right now. So it's funny that we're like this weird opposite. But Solid's async can work without suspense in the client. It isn't a great experience, but it won't crash. So does it make sense? Well, if it is held on the server, then we know that by the time we hydrate, we'll have all the async values resolved, which means that any future update will tear predictably. In a sense, we just skip the fallback and continue from there. So waiting does work, well, at least on the surface. What happens if we encounter new async? Lazy or data fetching behind a conditional? Then we're back to square one of not having a suspense boundary above it and no fallback to show. Yeah. So what I'm getting at is, does this make sense? I'm just to throw a playground out here so you guys can see what I'm talking about. Is what if let's pretend that this. I'm just going to add something else. Let's just go const async data equals create async. And I'm doing this in solid syntax so you guys can understand what's going on. If you're familiar with the stuff, fetch something. What happens if we have something like this? And we're like pretty happy that there's no suspense boundary, and we've simplified things. But then we have some code that's like, I'll use solid show component. It could be a ternary, it doesn't really matter. But it's like show when count is bigger than 5, and let's now show async data. So we didn't need this data to render this page because count was 1, which is smaller than 5. We skipped right over it. We don't care, right? But at a future time, when count becomes bigger than 5, there's no suspense boundary for it to fall back to. That's all I'm getting at, is like RCs don't have this problem of future because they only exist for the length that you're rendering the page when you're on the server. You don't have to worry about this like client interaction. But if you're like talking purely client side, if you need suspense, you need suspense, or you don't need suspense, you don't need suspense because of the potential of new discovery. It's not as simple as saying that, it just works this way the first time. Does that make sense? You guys following here? Because if you hit that new async, it needs to go to fallback. It can't resolve it. It does not have the data to show it, theoretically. Now, this isn't like the best example because technically speaking, this async fetches eagerly in Solid's model. So like when it enters the new zone, it will have the previous value. So it might like in Solid 2.0's like model, this would actually work. But like you could picture if the data fetching was underneath the show component. So like there's no way for it to fetch below like before this ran, like it wasn't eager like this. Then yes, you definitely don't have the value. You definitely don't have anything to show. You like you, this is a situation where you would go up to suspense. Now, obviously, we could say like you don't need suspense in Solid's model, but you understand like this is a suspense situation where you could show broken UI. Like I think we've talked about this before. Like one of the classic problems here is like if you put a div in here, div, and yeah, everyone like inserts are easy to picture, but like what if it's like class equals some class like what if it's like this, like the tearing here could be unpredictable if you don't have a boundary involved, right? Because it's like don't get me wrong, there's transition models, there's other ways we could solve this, but like a naive tearing approach here will show the content without the class being applied until the class is ready. Like it's not enough just to be like, oh, sorry, it's not inserting anything, you know who cares? It's just blank. I mean, that's not always the best experience, but you can actually, if you have async stuff and you're just like skip without showing suspense, you can end up with weird holes. Not just like, there's some content not loaded yet, but like a class isn't applied or a source is missing on a link or something. You know what I mean? Like you could break in ways that you have no idea you could break. So we talked about this previously on stream. I called it unpredictable tearing. Okay. All right. So okay, is not waiting an option? So we talked about what would happen if we just were able to wait and not do the suspense boundary. So it's not waiting an option. Render string has no ability to do anything but return a string synchronously. So if it encounters async, its options are limited. It either errors or returns with holes, right? We just talked about it. The other position, if we want to just stream the data, not the HTML. Yeah, so what I was saying is, what if in a situation like this, the expectation is, again, this isn't a great experience necessarily, but could you just stream this out and then stream the data in from the server, and then when the data gets from the server, basically client renders the rest? That's kind of like the hypothesis here. It's worth pointing out there's a difference between no suspense and no async reads. It is possible to do async and not trigger a read via some sort of guard. Yeah. So what I'm getting at is conceptually, we've been showing this off on the Solid 2.0 Signals 2.0 stream, this idea of like async guards, but you could build a system where you're like, hey, don't trigger suspense under this condition. So it is, I do want to point out there's a difference between saying like there's no suspense and no guarded async. Like this can at least inform you that it's intentional. Like here, you don't know what the person intended. This is a messy. But if the condition was like show is when not is pending async data, this conceptually is like you could say without this you could consider that like an error, but like with this you can say like, look, we're informing that, hey, we care if this is async and this won't trigger, like a suspense. We're taking care of it ourselves. You know that this won't render until this is handled, right? So like there's a difference between this and just being YOLO, right? You could say that the YOLO version still is an error, but this version is fine because it's actually informing intent, and it's explicit. So of course, to do so is pretty intentional, but it does differentiate things so we control what we can't. The difference with guards is that they won't trigger suspense anyway, so they'd have to work if we were to have them. So in some ways, this doesn't impact our decision. And since there's a way to, maybe there's sufficient data streaming solutions. Can they work? I guess it's a better question. Like maybe these avoid suspense APIs, maybe these avoid suspenses are untenable. My biggest concern I see here is hydration. If the data hasn't resolved yet when hydrating in these cases, should be more or less okay since the HTML and the hydration state will match. But there will be some places where this could fall apart. So what I'm saying is like, if you assume that this hasn't loaded when it flushes, you're just going to get the button and then the client will be able to just render the rest in. Right. But if the data loads before the render finishes on the server, then you might be in a state where you actually have the data on the initial flush and you'd have to make sure that the client was communicated that information. Like what if some case the data is loaded and the others it isn't, like maybe it's in a cache. If they aren't present at flush time, we won't wait for them, so they won't have update on the server release. Though through some combination with suspense, they happen to be, then I assume that the data will have been sent to the client by the time that boundary hydrates anyways. The other issue is data loads before the client is able to hydrate, but wasn't present at the time of server rendering. This is the more critical one because I feel like this one you could like do something smart. It's a bit awkward if you went to hydrate expecting the HTML to resemble the data not there, but then the data happens to be there. Like it's possible that it takes longer for the JavaScript to load on the client to do hydration than like the stream of the data comes in. So like you almost have to replay the events in the exact order that they happened. Otherwise, you might hit an issue where you actually have the data and you go to hydrate and the rendered HTML didn't have the data and there's a mismatch. Like the server side would have to mark things not read async under suspense versus things that are. But what if in one place it's red and another isn't? What if under those there's different boundaries? Yeah, I kind of go on and talk about like complications with this. Um, Technically, I mean, you could take a stance that if it initially renders to not available, you hydrate it that way always, essentially. But like it's tricky if the same asyncs read under different boundaries. I mean, I'm not saying it's unsolvable. I'm just talking about lots of complexity in terms of making that decision. Um, Technically, the scripts appended at the bottom of the page run synchronously and in order, but they don't trigger actual hydration because the async page scripts may not be present yet. We'd almost need to have them be blocked by hydration to process. It's interesting. Lazy is another interesting thing, as it isn't something we can just serialize or haven't until now. Currently, server finishes and serializes data triggering suspense to hydrate, but lazy code may not be present and interrupts it. Yeah, what I'm getting at is server-driven mechanisms are where when the server's done. So when the server has rendered the code, when the server has loaded the data. But if you're kind of waiting to be able to for data load to be able to kind of hydrate synchronously for portions like different boundaries, it's kind of awkward that the client might not be like a lazy component's a perfect example. You're importing code on the server, you import the lazy component and you use it to render your thing, but the client has to also import it. So the fact that the server has imported the lazy code doesn't mean the client is imported it yet. So currently installed, when we actually go to hydrate, we do it when the service is done, but the client might actually not have all the resources yet it needs. Which and this is a tricky problem from a bundling perspective too, right? Because you can have the same lazy code have different hashes between client and server. So like it's not as simple as being like have the server being like, hey, we're gonna need this, so load it, and then when it's loaded, that's when you hydrate, because the actual file name could be different for the exact same chunk from client and server. So Yeah, it's interesting. Like right now, what Solid does under suspense is we hydrate synchronously. It's a lot easier. It's hard to have stuff hydrate coming in at different times because you have to kind of enter and exit hydration mode. And lazy components are one place where we do that. And I think it's messy, where it'd be great if you can just say, like, I'm going to hydrate when this block is completely ready. And that includes a client side stuff. But because of asset management and bundling, this is actually tricky unless your server side rendering system is actually aware of how things get mapped by the bundler. It's not beyond something that that I'm thinking here. I know Nuxt has a trick where they actually compile in like unique identifiers on both sides, like because you can always use the source position in the source code because that's the same before like it's bundled out like into the different environments to actually get a constant identifier that's the same on both sides. But that requires processing of all your files and not just like some JSX somewhere. So like there's again manual and then compiler based solutions, but it adds this kind of layer of complexity. If we could hold off hydrating boundaries until lazy code is loaded to make things easier, we need then code where suspense relied on certain code and hold off to settled. If we want any particularly in terms of data resolution hydration, we need to run the whole boundary synchronously. Yeah, bang. Okay. So is no top level suspense a thing? It seems not waiting is complicated. Technically, it could work, but there are a lot of edge cases unless we basically replay the timeline on the server on the client. I also don't think, unless intentionally guarded, not waiting is behavior we want. Waiting works in the simple cases, but falls apart when something new happens under a conditional. But this is always a problem, even when with tearing async, and it isn't really an option for rendered string. Suspense at least sync bails out. So maybe all of this is more about setting more general rules in perspective. Let's create a hypothetical rule set. On the server, render string requires top-level suspensive guards. It doesn't have any complications with timing since it needs to fetch on the client anyways and doesn't wait on the server. So we just error out if unguarded async makes it to the top. Right. Because the thing is you don't have to worry about async hydration with render to string type of method for rendering because you know that you can't get more HTML from the server later, right? Like it's over. Once you've got that synchronous chunk, you're done hydrating. Other render methods wait on the top level for async. We need to consider if we should respect a guard provides. In the client, user effects can handle async without suspense. Unresolved async read in a render effect with no parent suspense errors out. Unresolved async reads under suspense transition can be guarded. And new unresolved async read under an existing suspense logs a dev warning suggesting to use nested suspense or a transition. What this would do is SSR would work without suspense, but the second someone did any new async used in rendering outside routing, which is done in a transition which is safe, it would error. So basically, if someone just starts adding random asyncs under conditionals without boundaries, it would break. Does this save us from needing defer string request async? Only if we value was read in the topmost suspense. This is something that could happen with meta tags, I suppose, worth exploring. So I think you could have an application with no suspense if it was very basic, i.e. no major UI changes outside router transitions. But even then, I'm not sure this would be great. But as a baseline, that can be a reasonable with run once. But almost immediately beyond that, you'd have suspense, and we probably need to be pretty aggressive in directing people that way. Yeah, there's some fun with that, and honestly, we're in a weird, as I said, we're in this place where like we can start using compilers to solve everything at this like level, and I've been resisting this as long as possible. Like philosophically, people don't solid is the probably nowadays the least compiled of the main frameworks, ironically, because React now has its compiler. I would say React and Solid were about the same before, but we actually use compilers less than everyone else. Even though when Solid came out, everyone thought we were like Svelte, but we are not. We are the least compiled JavaScript framework, ironically. I really, I think as long as you denote things for compiler explicitly, it's fine. But it is dangerous to like where edge cases come out when you have like implicit behavior around compilation. Yeah, I mean, I thought about SSE for a while because one of the problems is you can't guarantee that you have persistent state. You have to assume that 90% of people can't like are not incapable of opening WebSockets. So it can't be the general solution. Like it's great where you can, and I have people on the team like Dev who are very deep along that lines. But generally, average person throws something up on a Lambda function, does not get WebSockets. So um, it's tricky. I mean, I've tried. I don't know if more server client communication. I mean, it is. We can still play along that original stream. I think we just need to. The server has to be aware of the client bundle. That's the gist of it, right? As long as the server can be like, hey, you're going to need this, then we're fine. I just haven't found a generic solve for this yet. It'd be amazing if I had a generic solve for this. Like we already have the protocol. The initial HTML being rendered down has the capability of doing all this without opening a second connection. Yeah, I mean, we say that, but then we're going to talk about the async proposal in a minute. Svelte definitely see. It's kind of interesting. You say like Svelte's more runtime, but the thing is, Svelte now compiles files that aren't just Svelte files. So in a sense, the scope of their compiler has actually increased, which increases the potential of edge cases, I guess to speak. So like there's a I guess the what magic means different things to different people, but like the bounds of compiler are an important aspect. Oh, really? I thought you already had suspense boundaries. Okay. Anyways, it's so funny. Like we're I'm kind of wondering if Dan Abramoff's right, and we'll get to this in a few minutes. It's just funny. Solid was the only framework of the big ones, like and we're not big, but like fifth, I guess, or sixth, that actually implemented transitions alongside React. Um, back 5-6 years ago, and everyone told React they were wrong, and I was like, no, React's transitions are good in a certain use case. Just the one that got demoed by Dan with the stupid radar thing is not that use case. There's a huge value to them. It's just, but most people are like, no, we don't need this, and it's like, we'll talk about it more. Okay. So yeah, anyways, what I'm saying is we could kind of let people get by and then kind of like error on them to direct them the right way once they get there. So, but that's like, is that the reality we want to live in? What we could also just set rules and be like, no. As I said above, I think the ideal world suspense boundaries would only hydrate when ready, which relies on execution for the server to gather async resources. Since code CSS other assets are not things we can just serialize, I believe we need to communicate to the client to load these assets and hold off things until they are ready. It's tricky though, because I believe it's possible for lazy imports to have different hashes to client server to map them yet. So what I'm getting at is, I'm wondering if in a world where literally, how Vite has manifest for client to server, where like we expect a format like that, and then we're like, okay, guys, I know this is kind of weird, but our render to stream or render string to actually work properly, like right now, you could say it's an optimization, but to actually work properly, you have to pass in your bundler manifest. I don't know if I want to go that far, but it would make my life infinitely simpler. I think, like for me, I think that's preferable than say come up with something where you go and compile every piece of code and hope that you hit them all. Yeah, I mean, it's interesting here talking about magic is like technically speaking, I agree. When hooks came out, things got much more less clear for people. Pre hooks, React was really easy to explain. Post hooks, the fact that this thing is persistent in the background is harder to picture. I mean, it's not that hard to picture. You can think of context as a perfect example of where React does this later, but um, it definitely that was the point where people stopped being able to just like go like, oh, I feel like I could write something like React in a weekend. That's when people are like, what the hell is going on? Definitely from the fact that they are no longer using the compilation to do reactivity, and rely more on runtime. It removes some of the like it just works kind of magic aspect. I just meant like the scope of yeah, it's I guess it's less magical, but the scope of compilation has increased. So it's like the concern about how invasive it is are still there. I mean, at this point, from an output standpoint, like view compositions felt view with vapor felt like we're not really that different. I think there's a philosophical thing we need to look at in terms of where it sits. But I mean, well, I mean, most people know this. Vue had a proposal for something that looked basically like Svelte runes, like 4 or 5 years ago around because they saw Vue was like we have this fine grained reactive system with composables, and then they were like, huh, everyone's going to Svelte because it's easier because of simple syntax. So they tried to apply, um, their own dollar sign syntax to Vue. It was called the ref sugar thing, and in the end, runes and that ref sugar look very very similar. I know because Alexa saw the Vue proposal and made a library for Solid 5 years ago for the same kind of thing. So, like in a sense, now we've gone to a point where the baseline is all very, very, very similar. Yes, yeah, yeah. I think that's fair, and in a sense, Solid hasn't leveraged this yet, but we were kind of using like we can use the .jsx extension if we wanted to do that. Like essentially, we could say we only process TSX or JSX files. So I've considered this, and I think this is yeah, yeah. They deprecated for the same reason that I didn't merge it into core. I thought it was worse than the problem that it was solving, especially when you start thinking composition and they start having these double dollar sign out things. What Svelte did come up with a well, first Svelte 5 didn't solve the problem, and you had to, you know, pick your own wrapper, which I think was better than the dollar sign to be fair. But then later they got the class mechanism for kind of auto compiling into classes, which is a little bit nicer ergonomic than the dollar sign. But I mean, obviously, I still stand by my original position. But I'm free to have my opinion, which is different than others. I do think what runes solve personally isn't worth the effort compared to like the problem. Like the problem is as bad as this, or the solution's as bad as the problem. But that's just like my personal thing. I can see why some people would think differently. Um, anyways, that's the first of our SSR discussion today. So I think that the highlight on that one is simply suspense is probably just a good thing to have. Um, yeah, because newborn and kid pickup times and stuff, I'm probably going to start streaming earlier from now on. Yeah, yeah, that's true, and that's the same problem we had with Signal's early days. They weren't even compiled, and people thought they were magic. It's but what's interesting is once you know, how do you feel about it once you know what the transformation does, right? And the other question is like, how much do you need to know what the transformation does to actually have an accurate mental model of how this thing works, right? Like my favorite example, although that's the class compilation thing fixed it, but like favorite example was if you made a like a dollar sign state ruin and you return it out of another file, you had to wrap it in a function or in getter or something, right? And it was like, why, right? If basically the abstraction didn't protect us from having to know that everything reactive is a function. So like at that point, that's when I asked the question: is it typing two less characters worth it compared to the cost of abstraction from a conceptual thing? When it, you know what I mean? Like you, if you have to know how it compiles anyways, then what is it doing for you? As I said, different ways to solve that. Different ways you can just go deeper and come up with different mechanisms to hide that or that. But like that's the sort of question. It's right. Sometimes. I hope so. I mean, I'm a big fan of proxies, as you know. Yeah, when you know the transformation, it does stop feeling magical, but then you also have to ask the question: does it feel worthwhile? So it's like it's a tricky one. Anyways, um, so let me see here. Where was I? Right. Okay. So I have back in February or January, I set out two things I wanted to fix with Solid's async, and this is again, let's get in this mindset. Um, and keeping what we know in mind, I pinpointed two issues with our async, our SSR. SSR doing re-renders on the server. While Solid has been so fast rendering on the server, it didn't matter. At a certain point, somebody's like, "Look, my memos are expensive, or some of the things that I don't like keep with those resource IDs are expensive." It's not expected. In Solid, everything runs once. Why on the server does this component now run like 3 times? Because of nested suspense boundary timings and stuff. Usually suspense is kind of blocking, sort of, because of stuff failing out. But actually, that's not because whether it's an undefined check or throwing, like usually it's like something is blocking, but some cases it's not. And this is like that problem that React had, right? Because originally they were like, "Hey, we just process all the siblings and continue on our with our merry life." But then, as when they released React 19 RC, some point in the middle, they'd been like, "No, no, we're just going to stop on the first async." And because it saves time, we don't have to render the whole rest of the thing every time. Well, Solid does render the whole rest of the thing time. Maybe it renders 10 times faster than React, but it still renders, right? So like that's something I wanted to fix. And then the other thing was like hydration IDs in the templates. I you guys may remember there was that benchmark thing, and it drove it was a little bit. I spent so much time optimizing Solid's SSR down to the JSX level in bindings that when you turn off hydration IDs for Solid, it was the fastest server-side rendering in that Fastify benchmark. It was faster than someone who just doing a naive template literal. It was basically faster than every other implementation that they had there, even just like using a string in Fastify. And you might be like, how are you doing this? Because the compilation, we can be smarter than just using a tag template literal. You guys know tag template literals hold memory around because they keep the arrays in memory. Like this is how lit works. Like every time you run the tag template literal again, it actually has a reference to the static nodes, and then you can put your bindings, basically attach it to there, so that you don't have to like redo it. That's why lit can re-render over and over again without a virtual DOM, because it actually keeps the static references. But in SSR, do you want to keep those static references? No, it runs once, presumably, in a fast benchmark. So like there's a lot of places where you can optimize performance. And I basically gone very, very fast for Solid's SSR. Then you add the hydration IDs and the size of the serialization offset it. And instead of being 30% faster than every other framework, it was, like 10% slower than the fastest. So, I mean, this is a minor gripe because it's not representative of real world applications, like creating 2,400 elements, in a tight loop, causing, as I said, we do chunks. So there's an ID per element. But, if there's a place we can improve, these are two areas. Right. So I've kind of been working on two different solutions to these problems, and I want to kind of talk through them in terms of designing them. Um, One of them was the first one is what I'm calling pull-based SSR. This is very, very inspired by what I showed on stream. If you guys remember, I had a stack blitz from a previous stream, which I have not signed into for a while. Can you with GitHub? Where I was showing, yeah, I think it's this one. Whereas showing this example with like the self-healing error boundaries, right? If you guys remember this code, I wrote something where we have some signals, we have some async, and some memo that transforms that async. And essentially, there's a suspense boundary up here, an error boundary down here, and inside that, another suspense boundary, and some kind of async thing we're doing here. But my point is, what would happen is when it throws or errors out, um, even though the data fetching is way up here and not related at all, could be in a different component, we don't really care. Because it's in an errored state and the error boundary collects the render effects that error out to know if it's thing, we have the ability without rendering this component to both when it errors, see, both either retry, which essentially just says pull again, just ask for uh for the data. Like it basically just tries the data fetching again automatically because it goes, okay, this async has failed, let's pull, right? So, doing this, or without rendering again, let me get another error. If I click here, it also clears out the error boundary state because it goes, oh, the node that we previously collected, well, it's no longer errored. We can remove the error boundary again without re-rendering anything. So like essentially, I was very inspired by the work in this zone because I was like, if we can just collect the things that aren't ready and just try them again, we know when we want to try them again. When async resolves, couldn't we just do our SSR this way? Couldn't we just SSR is concatenating a big string, but until we combine it, it is an array. If each hole could be resolved independently, templates are the sinks similar to render effects. We could combine as best as we could, leaving some holes where async. And as the async resolves, it approaches one string. If we separate creation from pulling, we shouldn't have to rerun any components the same way we don't need to rerun with suspense. It just pulls out the expressions. We don't need reactivity as promises themselves can repull. What I mean is it's not push based. It's not push pull. It's literally just pull based. It's basically identical to client resolution pattern, but it doesn't since it doesn't update, it only needs to resolve once, right? So basically, you collect the nodes that aren't ready and you pull. And it's I'll talk about more in a minute. The other idea I had was the reason we have hydration IDs in the templating is because of JSX can be created out of order. See, Svelte has this and Vue have this advantage over us in terms of hydrating because solid can do this, which is a little bit awkward. Solid can do this. Don't get me wrong, this is a freaking superpower, but solid can do this. Okay. Still works, right? You can literally create a div with a reactive binding up here and just stick it inside the thing here. Like I can create my JSX in any freaking order. I can import it from somewhere else. I can bring it from, like this is why I love JSX. I think JSX is incredible because it's incredibly portable. You can literally just go like pick it up and toss it around. Obviously, we tell people most of the time in Solid to do this because the advantage of doing this is that some people make the mistake when they see this to think that because it makes a div element and they might do something like this. And if you know anything about the DOM, an element can only exist in the DOM in one place. So doing this is not good. It doesn't really work. Whereas doing this, I must have TypeScript turned off, does work, right? So it's just something to consider. And in a sense, this does defer the load. But my point is, it is always possible to create stuff out of order with JSX because it's portable, right? Even in this scenario, what's the order of creation? Oh, I want the client side output. What's the order of creation here? Okay, yeah, so it does create the button first. Okay. Good to know. Okay. But generally speaking, this aspect of GSX is incredibly powerful, but also sorry, these aren't but also as you can imagine means that we can't just like we don't know the parent. I mean I use this as an example, but you can picture this even conceptually here. When counter gets called, we have no clue necessarily who the parent is. We can't say you're going to be inserted into this. Like who's the parent of div? And like even if I wrapped it in a function myself, how do I pass in that information? Like now this is a component conceptually, right? That's all I did here. I just made it a component, right? I mean, I called it as a function, but this is conceptually a component, right? Um, like how do I know what the parent is? And you don't because it's potentially unless like we pass something into the function to tell it, hey, like when this is actually is a component, parent is the first argument or something. Unless we did some kind of like advanced compiler, not even advanced, but some like extra compilation information, we don't actually know what the parent for any element is. Is div variable works on client side? Yeah, I mean, sorry, I don't. I mean, technically, this works with SSR too. Um, what I'm showing off here. Um, this is just like a fact about GSX. See if and part of it is like because you can also have like 10 components on the page, right? Or like in this file. So like it's just a function. So when you have a single file component, you can be like, look, there's rules. We can control what things we export. We can massage the signatures to fit our stuff. Like this is why a long time ago I said that I think that single file components have an advantage for SSR. They don't have any advantage necessarily for client, in my opinion, but for SSR they have this advantage because of a certain amount of analyzability, being able to control the exports. They could even have advantage also probably for like hydration as well because of this extra layer. But I said the portability of this is just unmatched. I can make 10 child components inside my component that like it's just it's super powerful. It's just it restricts us on like very specific rules. So um So the key challenge is we need to collect nodes so they can appear in effects expression. This happens early in the template, but what if we didn't need to? So I had this other idea of like, what if we actually proxied elements while we created them and then realized them during hydration at the end? I'm going to go into detail on both of these, but essentially this is the kind of like the hypothesis I had in it. I kind of came up with this kind of, I think over Christmas break and I wrote it down sometime in January. So let's explore deeper into both of these. So let me share this one. This is called pull-based reactivity for SSR. Okay. The idea here is if that we can avoid component re-render. Sorry, my headphones are not coming through. Oh, do you know what it is? My mic's quiet today. Nobody told me. Sorry, my mic's been quiet this like whole stream. Oh well. Is that better? I'm now I've like probably blew everyone's eardrums. No. Sorry, my mic's been very quiet. Okay. Well, hopefully that's better. Okay. Okay. Well, you guys there's probably some like built-in compression on something or other. So I don't know. It sounds better to me. I sound crisper. I feel more dynamic range in my vocal envelope. Okay. Okay. So okay, the idea here is that we can avoid component re-registering SR by repulling the result as async results. The idea is simple, but some repercussions to the system. Let's look at designing this works. Right. So what do you think? If we're going to do a pull-based system, what are some design considerations we have to consider? Well, first, that if it runs once, nothing but async state can change during SSR. or things derived from async state. There's no notification, no push-based reactivity here. So if a value would be set, it has to be during initial render. Since events and effects don't run during SSR, you shouldn't be writing during the pure part anyway, so I think it's fine. What I'm saying is, and we have this constraint in Solid today, like it kind of works because sometimes things re-render, but you shouldn't like create memo and have it write to a signal like that's higher up that happened to like already render some stuff. It might not update. But so as a prime thing here, you shouldn't. I think the reactive system and reactive rules generally have you here, but this is a good assumption and thing to put forward. I don't know if you guys have situations where there's like, it's one thing to have like a signal and then like a crate computed right after that writes the signal for initial value to sync with props because you haven't rendered or used it anywhere. That would be fine. But with Solid 2.0's design, we're avoiding that anyways, right? Because instead of doing, you know, just scroll down here for a second. Instead of doing const name, let's use name, set name equals create signal, and then be like create computed or effect or whatever. Instead of being like set name props dot name, right? Instead of this being a thing, the Solid 2.0 version of this is name set name equals create signal props dot name, right? So you write like you're already in a zone where we're saying like don't call the setter, right? Like this, like at least not like the only other time you'd be calling set in these types of examples generally is like when someone clicks a button or does an effect or does something, and those don't run on the server. So technically, this should, I think this assumption's a safe assumption. Okay. We need to be careful to watch on performance. Not collapsing to strings seems to have a negative impact on performance. Our pure string approach appears to be the biggest difference with the Solid, say from others. Now, to be fair, Svelte does use a string approach, but I don't know a pure string approach, so I actually think the performance is actually pretty similar. I don't know why I mentioned Svelte. It should be. I think I meant to say a different framework here, but it's. It is we don't have any intermediates, and some of the other two strings like actually do have intermediates. So this introduced an intermediate again, which is slow. And I actually benchmarked this, and sure enough, it is slower, at least in my naive approach. I'm thinking of how we can make it faster, but it is definitely, it definitely takes a performance hit. So looking at SSR template functions. Right now, a tag template literal, that SSR function I showed you, and it goes through stitching strings with holes that can be strings or numbers, functions, i.e. reactive values, objects with T, which signifies that they're already processed template, and arrays of other value values. So yeah, this is part of why we had the SSR function. It was because you can put the previous example here, where you put JSX and JSX and JSX like this, and we handle it generically. We needed a way of being able to say like, look, this has already been escaped. Don't escape it again, right? If we look at the server-side rendering of this, see how this calls escape around create component, because it doesn't know, generally speaking, and around count. But count will not be escaped twice, because what gets returned from this SSR function is a template object that will pass through this escaping. It will assume that it will be like, I've already been escaped, I've already been processed. So this is kind of key to what we were doing for our design here. And then it can also be an array of other valid values. So yeah, I'm talking specifically here about this SSR function that I've been showing here that kind of stitches the strings together. So it's conceptual here. And we assure that all objects become and we sure that all becomes an object with T, which carries the string. Solid today doesn't even really compile the functions for these native templates because they run every render like React. So we have, for the most part, just been jamming strings into objects, which then jam into strings as we compress up. Why objects? To prevent double escaping. Escaping assumes that these are processed in the easiest way. As it turns out, not compressing as we go is slower. I.e., if we keep our object around a long time, then compress at the end, it's actually slower than compressing as we go. So Unsure if we have any options with async. We need to see if string replacement is faster than objects, because with async, you can't melt everything into a string without at least markers. Yeah. So another option you could do is, instead of keeping these objects, like unresolved arrays or holes, you could actually just like make markers in the string and replace them. I don't think this is faster, probably at a certain point, but it's worth a question. Concept here is we compress the best we can, but then we rerun any remaining holes when async completes. As we run our SSR method, we try catch each hole. If it throws not ready, which means it's like got a promise, it's async, we can't flatten to a string and return a template with the resolve string with breaks for remaining holes, the whole function to rerun, the ownership context of this template, and collected promises. This is the tricky part, because you have to resume context or the reactive ownership scope when you rerun these holes. Parent templates may come across children in the state. They too can flatten best they can, combining resolved values and templates to holes and waiting on promises. However, they won't try to rerun incoming hole functions and unresolved templates. This combining suggests that holes may need to keep their own owner reference, because once combined, adjacent holes may need to run in different contexts. The responsibility of rerunning these holes will fall to suspense and at the top level. Effectively pseudocode. So what I kind of pretended I wrote this function to kind of get an idea of what it's doing. It's like promising all the templates promises while true, and then it gets the result, which puts the first part in, and then makes a new collection for promises holes, and then goes through the templates holes that currently exists. So the thing on the template are what's current, and this is like for the next iteration, what it collects. So gets the template holes, tries to resolve them, run with owner with the owner that's passed in, and then if it doesn't throw, essentially append it to the other part. There's a bunch of logic here. It's not too important, but I think you can kind of see how it's like basically pushing the stuff along and combining as it goes. And then if it catches an error of not ready, this is basically our promise error, we rethrow. So we rethrow any error that's not that. So go to like error boundaries and stuff, right? Otherwise, we assume that it's async, and we just push the current thing in instead of merging it in. And then finally, if at the end, if there's no holes, we can return the result. Otherwise, we update the template with the new list, and we do it again. It's pretty cool that SSR becomes a do while true loop. I mean, this is kind of more conceptual, but the point is like, it just sits there doing it. We kind of created a generator, if you think about it. We're just sitting there and we're like, while true, await all the promises. When the current ones are finished, go through again, try and combine it. Is there any more promises? Do it again. And just basically until it can sort it out. But what's cool about this is, as I said, is it's just rerunning the holes in the SR function. It's not rerunning any components this way. So how does this work with suspense? Well, suspense returns the fallback without returning a template with holes unless the fallback itself has holes. So this means that the parent can fully resolve and flush, and stream it out. This means that suspense boundaries do still need independent registration, so that when they complete, they can flush themselves, as well as potentially, if they finish before other elements of their parents do the string replace. What I mean is we have this mechanism, we have it now, where if the child suspense finishes before the parent suspense, we combine it with the parent suspense, so they all get sent out on the same thing. But because it's already reported to the parent that it has its fallback, we have to go in and swap out the fallback with the finished content. And again, we do this on the server instead of waiting for it on the client, just make it a little bit faster. And that's all I mean here. It's the reason that we had to do that swap is because we've already combined it into the finalized string, because you can always stream out a fallback. So it views itself as like finished to the parent's perspective. Anyways, in a lot of ways, things aren't that different than today for server rendering part. Hydration is a different question, but we'll get to that. One thing that could be worth trying is not keeping what I call the parts above in an array, but instead put them all in a string with some sort of noise marker and do string replace at resolve time. I expect this won't be as performed, but we have to look at object allocations. Like in the real code part, wouldn't be an array, it would be a single string, and we just upgrade it to arrays as needed. We might also need to look at monomorphism in terms of the shape of these template nodes. They are sort of like VDOM nodes, admittedly, but more like block DOM than individual, and only when things can't be resolved initially. So what I'm saying is, if you think about it, kind of like at a distance, each of those blocks of SSR functions that return these template objects are forming a tree when things are unresolved. So in a sense, they almost form a kind of temporary virtual DOM that then flattens as the async resolves. So we might be able to find optimizations from there. It's also possible the whole compress as you go might not be worth it in real async scenarios. The problem is I'm not sure we'd ever be able to tell because async already adds more delay than we typically capture in tight SSR cycle like benchmarks, and those being synchronous would always benefit from early evaluation. Yeah. I mean, this is what I'm getting at. Benchmarks are generally synchronous because async is unpredictable aspect of it, right? Like, so like generally they're always like testing how fast can I jam strings onto the page, which means that even though early evaluation is always beneficial in those cases, it's basically, it'd be very hard to measure that it wouldn't be. You'd have to come up with a situation in which involved async in a predictable way and figure out what was like maybe something very expensive happening after the async to really show the benefit here of this approach. This is one of those thankless approaches. React has a lot of these where they build something that doesn't end up improving any sort of benchmark, but it should be better because the execution model is better. So like, yeah, I mean, it's always tricky. React compiler is actually one of those. If you think about it, React compiler doesn't make React any faster, right? So when you try and create any controlled scenario that's like at all reasonable to create, it actually doesn't end up with it being actually faster. But you know that when you put it out in the real world and there's messes out there, there is benefits to it. So it's like it's tricky. Conclusion. Anyways, this is basically the thought for now. Nothing really too complicated, nor did I anticipate it to be. The problems all come when we start looking at hydration. Timing is critical if we want to figure out how to drop hydration IDs, but given things like create unique ID and async serialization, we probably need to generate them anyways, even if we don't write them to the DOM. So there may be complications in terms of server rendering performance to consider, but I did confirm it was the HTML output causing the bigger slowdown for the hydration IDs, right? Like we could generate them and just not serialize them, and that was faster in benchmarks. That being said, none of this overhead is the big compared to the actual work needed in user code to actually present the data or to render the page. Yeah, I mean, the biggest struggle here is I think technically speaking on those like fast SSR benchmarks, this approach will be slower than the overhead of the hydration IDs, ironically. So it's funny where we're like, we keep kind of saying like, you can basically make it so that there's a better, more consistent server output that works consistently with async the same way Solid works in the client, and it's actually a better model. But we actually take a bigger hit than the actual serialization of the hydration IDs, which inspired me to start on this work in the first place. But we won't know until we've actually optimized it all. But this is where I'm sitting right now. Okay. And then, I don't know, I need to drink some water. I've started building the compiler this week for this poll-based SSR. There was some of you might have remembered I put a poll up on X a little while ago, and I was like, where is my profile? Why am I not seeing my profile? It's probably still here. Okay, I put this poll up, and I was like, hey everyone, experiments for Solid 2.0 now encompass all approaches to client async and storage and server, but implementing them all at once is a bigger lift. We could keep the current server and release it later in 2.0 or even in a 3.0 release. Like what I mean by that is like we could just like keep the re-render server stuff like we've been doing forever and just like focus on the cool client side stuff that I've been showing you, like this stuff, like the non-blocking async and all the cool stuff. We can like do this new SSR later. And most people agreed that made a lot of sense. Unfortunately, like literally the day after I posted this, I came to a realization and actually re-implemented it. You can actually see it on the current next branch. I actually re-implemented server-side rendering, suspense, everything on this for SSR using the old re-render model. It's currently committed. It's been released, experiment 0.5 or whatever. We have fully working SSR not fully working hydration, but we actually have fully working. Well, technically, error boundaries don't work over suspense because I haven't re-implemented the that requires some hydration coordination, like throwing suspense, throwing errors over the boundary and having the client side suspense catching the errors. I haven't re-implemented that part yet, but other than that, like streaming, lazy, all the stuff works. But then I realized that I